Good day, everyone. I'm Mr. Garth Reed, Student Ambassador for the University of Technology, Jamaica, and Mathematics Teacher in Training in the School of Mathematics and Statistics. Today, we'll be looking at a Pure Mathematics Unit 2 question in Module 2, right? Which is Sequences, Series, and Approximations. And the topic that we're focusing on is using sigma notation. All right, so here we have our question, which says, given that Sn is equal to the summation from I is equal to 1 to n of I cubed minus I, where n is a natural number, find a fully factorized expression for Sn. All right, so let's get into the question. So they gave us that Sn is equal to the sum from I is equal to 1 to n of I cubed minus I. So what I can do here is to just separate this as two different summations, right? So let's look at it. So I can write this as the summation from I is equal to 1 to n of I cubed, right? Minus the summation from I is equal to 1 to n of I, all right? So let me just refresh your memory on these formulae that you should know, which is in your formula sheet in the Pure Mathematics examination, by the way. So recall that the sum from I is equal to 1 to n of I cubed is equal to n squared over n plus 1 squared, and you would divide that expression by 4. All right? You divide that by 4, and the other one, which is the sum from I is equal to 1 to n of I, is equal to n times n plus 1, and you're going to divide that by 2. All right, so those are the formulae that we'll be focusing on for this question. So let's get into the question now. So this is equal to, so the formula for the sum from 1 to n of I cubed, we know is n squared times n plus 1 all squared over 4, right? And we now have minus the sum from 1 to n of I, we know is n times n plus 1 over 2. All right? So what we need to do now is to just combine these two fractions and simplify. So this is now equal to, I'm going to let 4 be my LCM. All right? I'm going to let 4 be my LCM. So what I will have in the numerator is basically n squared times n plus 1 all squared minus 2 times n plus 1. All right, that is what I will have in the numerator. So I still have 4 in the denominator. What I'm going to do now is to factorize n plus 1. You recognize that n plus 1 is a common factor here, right? And n plus 1 is here. So we can factor out the n plus 1s. So what I will have now, oh, and clearly we can factor out an n as well, right? We can also factor out an n as well. So n is common. So what we can do is factor out an n, and we can factor out an n plus 1. All right? So when I do that, what I will have remaining inside the brackets is n times n plus 1, right, minus 2. All right? That is what I will have. So let me now simplify. So this is now a slab 4 in the denominator, and I now have n times n plus 1. When I multiply the n times the n plus 1, I get n squared plus n, and remember, we have the negative 2 there. All right? So we can go one step further because we can factorize the quadratic expression, all right? So if we have n squared plus n minus 2, we can factorize that as n plus 2 multiplied by n minus 1, all right? When you multiply two numbers, you're supposed to get -2, and when you add them, you're supposed to get 1. So those two numbers are 2 and -1. Good. So let us write in our factors. So we have n times n plus 1 multiplied by n plus 2 multiplied by n minus 1, right? And we're dividing that by 4, all right? So this is Sn, which is n times n plus 1 times n plus 2 times n minus 1 all over 4. And that is our fully factorized expression for Sn, all right? So we have now completed the question, which is using sigma notation, right? That's the topic that we're working with in the Pure Mathematics Unit 2 syllabus. In Module 2, Sequences and Series and Approximations, I'm Mr. Garth Reed, Student Ambassador for the University of Technology, Jamaica, and Mathematics Teacher in Training in the School of Mathematics and Statistics. I thank you for joining.